I'm not referring to the people next door. I'm talking about extraterrestrials, and not just any extraterrestrials. I'm referring to sophisticated societies, entities that have discovered how to construct spacecraft, radio telescopes, perhaps even far more advanced technology than anything we can conceive. What bothers me is that given the countless stars scattered across the universe, given the multitude of planets orbiting them, we ought to be overwhelmed with transmissions. Yet we detect absolutely nothing. And today I want to discuss with you the reason behind this. But here's the unexpected part, and this is what genuinely disturbs me. I believe the explanation might not be that extraterrestrials don't exist whatsoever. I believe that perhaps, just perhaps, we arrived too late. We showed up to the celebration a billion years after it ended. Allow me to begin by doing what I consistently do. Taking something that appears complex and separating it into manageable pieces we can truly contemplate, because that's genuinely the only method to comprehend anything. You must grasp it element by element. So, let's examine how many intelligent societies ought to exist, and indeed, there's a mathematical formula for this. A physicist named Frank Drake created it around 1961, and it ranks among the most renowned formulas in science, second merely to Einstein's EXL squared. Now, the wonderful aspect of this formula isn't that it provides us with an answer because, honestly, we don't know most of the values. But what it accomplishes is it compels us to think systematically about what we need to discover. It structures our lack of understanding, as one scientist phrased it, and I appreciate that expression. Here's the concept. The quantity of intelligent societies we might identify in our galaxy depends on various factors. First, how many stars come into existence annually? Well, we're fairly accurate at measuring that now. Approximately 1 to 3 sun-like stars appear in the Milky Way every year. Next, what portion of those stars possess planets? Well, we previously believed planets were uncommon. We hadn't identified any exoplanets until 1995, but currently we understand that nearly every star hosts planets, possibly 1, possibly 10. And certain planets reside in precisely the appropriate region, not excessively hot, not excessively cold, where life could potentially thrive. We term this the habitable zone, the Goldilocks zone, perfectly suitable. Now the intriguing section, the section where matters become unclear, concerns how many of those habitable planets does life actually emerge on, and subsequently of those, on how many does intellect develop, and of those intellectual creatures, how many actually create technology. How many construct radios and telescopes? Well, examine us. We exist. We accomplished it. Consequently, the likelihood exceeds 0. That portion we definitely understand. However, there's one value in that formula that absolutely bewilders me, and that's the final one. That's the duration of a society. How extended do advanced societies persist before they vanish? And here's why this troubles me so deeply. We possess only one illustration, ourselves. And we've solely been transmitting radio waves for under a century, 100 years. Compared to how many millions or billions of years that life has existed on Earth, it's similar to observing someone exist for 3 seconds and inquiring how lengthy do humans typically live. You simply lack adequate data. Consequently, when you combine all these probabilities collectively, you obtain a spectrum of results. Some researchers suggest there ought to be thousands of societies in our galaxy. Some propose possibly millions. Frank Drake personally, when I most recently heard, estimated there might be roughly 10,000, but other researchers examine the identical formula and arrive at a result of perhaps 1. Just a solitary throughout the entire galaxy. The outcome relies completely on which suppositions you adopt about those uncertainties. Now, here's where it becomes fascinating. In 1950, a physicist named Enrico Fermi, brilliant individual, Nobel Prize recipient, sat down for a meal with some coworkers and he began contemplating this identical dilemma. And he became so disheartened that Enrico Fermi, this giant of physics, grew melancholy. Genuinely melancholy because he understood something that doesn't quite fit. He stated, "The extraterrestrials, where are the visitors from advanced technological societies? Because, consider this, we have approximately 200 billion to 400 billion stars merely within our personal galaxy. Many of them are more ancient than our sun, billions of years more ancient. Some of those more ancient planets must have contained intelligent life. Some of those must have created technology. Some of those must have discovered how to journey between stars, and if they reached that point, they could have expanded across the entire galaxy using merely moderately slow spacecraft. Nothing sophisticated, just slow chemical rockets moving at a portion of light speed. They could have populated the whole galaxy in merely a few million years. That's insignificant. That's an instant in cosmic terms. The galaxy is 13 billion years old. So why don't we observe them? Why doesn't our sky resemble Grand Central Station during peak hours? Why don't we detect their radio transmissions? Why hasn't anyone touched down on our world? This is the Fermi paradox, and it is genuinely disturbing. So, what's occurring? Well, there are numerous potential responses, and I want to investigate them with you because they're all intriguing and they all instruct us about something significant. The initial response is the most straightforward. Perhaps we genuinely are solitary. Perhaps the likelihood of intelligence developing is so incredibly minute that Earth represents the sole location it's occurred in our observable universe. Now this appears bleak, but interestingly, Fermi actually discovered this oddly comforting. He highlighted something remarkable. He stated that we became extraordinarily fortunate. He termed it the anthropic principle. We exist. So clearly it transpired at minimum once, but perhaps the conditions that produced us were so exceptional that they could never repeat across a trillion universes. And if that's accurate, then perhaps we needn't be concerned about other civilizations surpassing us. Perhaps we're genuinely unique. But here's the difficulty with that response. Even if we're extremely uncommon, the numbers don't quite align. There are 10 to the 22nd power, that's 1, followed by 22 zeros, stars in the observable universe. Even if intelligent life is incredibly scarce, even if the chances are 1 in 10 billion trillion, those numbers are so immense that intelligent life ought to still exist somewhere. The mathematics simply doesn't permit us to be solitary. So that leads us to another response, and this is the one that keeps physicists awake throughout the night. It's termed the Great Filter. The Great Filter is a concept that genuinely unsettles people, but I believe it's worthwhile considering seriously because it's rational. Here's the reasoning. There are specific stages that life must undergo to progress from non-living compounds to a space-traveling society. Some of these stages might be incredibly difficult, nearly impossibly difficult. So difficult that extremely few, perhaps nearly no societies actually complete them. Allow me to enumerate some of these stages for you. Life must originate from non-living chemistry. That's stage 1. Then single-celled organisms must develop. That's actually fairly simple. But then something extraordinary must happen. Those single-celled organisms must discover cooperation. They must form complex cells with nuclei inside them. They must become multicellular beings. Fish emerge from oceans. Dinosaurs evolve, mammals evolve, primates evolve, and then eventually one species, merely one, discovers how to employ tools and create language and construct technology. We term this stage intelligence. And then that intelligent species must avoid annihilating itself long enough to depart its home planet and expand across the stars. Now, each of these stages is enormous. Each one represents a massive advancement, and perhaps one of them is so challenging that nearly no civilization that commences from basic chemistry will ever successfully traverse it. That would constitute the Great Filter. And here's where it becomes alarming. That filter could exist in our history, or it could exist in our future. If the Great Filter lies in our history, if it's one of the stages we've already crossed, then it indicates we're incredibly uncommon. We're one of the sole societies that progress this far. And that's actually encouraging information because it implies we're probably not about to encounter another one. We've already scaled the peak. But if the Great Filter lies in our future, well, that's horrifying. That means advanced societies similar to ours nearly invariably self-destruct. Perhaps they consistently wage nuclear conflicts. Perhaps they consistently develop artificial intelligence that rebels against them. Perhaps they consistently contaminate their own world with pollution. Perhaps they damage their climate so severely they cannot recuperate. Perhaps the instant a species becomes technologically sophisticated enough to expand across the stars, something inherent in technology itself proves self-destructive, some type of unavoidable self-annihilation. If that's the situation, then we're in difficulty because we're approaching that degree of technology currently. Now, there's something else I want to discuss because it just came to me, and I believe it's significant, and it concerns timing. It concerns time itself. You see, all of this discussion presumes that societies exist simultaneously. We imagine them distributed across the galaxy, all of them sophisticated and communicating, all of them existing concurrently. But that's probably not how it operates. That's probably not how it operates whatsoever. The galaxy is ancient, 13 billion years ancient, but that doesn't indicate life has existed everywhere throughout that entire period. Life required an extremely lengthy period to develop on Earth. We believe simple cells emerged perhaps 4 billion years ago, but complex life, multicellular creatures, those didn't appear until merely about 600 million years ago. And intelligent beings, we've solely existed for a couple 100,000 years. We've solely possessed technology for a few thousand years. We've solely been transmitting radio waves for a century currently. Envision this. Envision that somewhere in the galaxy on a planet circling a star that's older than our sun, life started earlier than it did on Earth, and it developed faster or perhaps at an identical rate, but simply commenced earlier. So intelligent creatures emerged millions of years ago. They built their societies. They became space traveling. Perhaps they expanded throughout their section of the galaxy. Perhaps they were remarkable, peaceful beings who discovered methods to exist for billions of years. But here's the crucial point. We don't overlap. We entirely miss one another. Consider it in this manner. Envision a celebration that continues for 1 billion years, but nobody remains for more than 1,000 years. You could have 1,000 societies at this celebration throughout 1 billion years, yet you'd never encounter any of them. You'd arrive at the celebration, you'd stay for your 1,000 years, and everyone you encountered would have already departed. And when you departed, everyone you encountered would have been absent for thousands of years. And the new beings arriving at the celebration would have never learned of you. That's what I believe might be occurring in the galaxy. That's what I believe indicates we missed the extraterrestrials by 1 billion years. Not that they don't exist, but that they existed. Past tense, they arrived and departed. They experienced their time in the sunlight, literally the sunlight of their star system, and then they vanished. And the subsequent society emerged 1 million years afterwards, and they vanished, and another one emerges. And we're merely one of thousands or millions of these societies, each experiencing our moment on the universal stage. But here's what genuinely disturbs me about this concept. We don't know if the timeline functions that way. We don't know how lengthy societies endure. And until we discover this, we're merely speculating. Allow me to share something that fascinated me when I discovered it. There was an investigation performed by researchers at NASA and Caltech that examined where in the galaxy life would be most prone to develop. And they discovered something fascinating. The thickest grouping of stars in our galaxy exists approximately 13,000 light years from the galactic center. That's where you'd anticipate the most life to emerge. However, Earth is approximately 25,000 light years from the galactic center. We're in the outskirts. We're in an isolated area. And they additionally computed the optimal time period for societies to emerge. They stated the most probable time for societies to develop was approximately 8 billion years after the galaxy formed. Our galaxy formed approximately 13 billion years ago. So that indicates societies ought to have been arising everywhere 8 billion years ago. 8 billion years. We've solely existed for 13.5 billion years after the galaxy formed. We're remarkably young. We arrived at the concluding phase of the celebration, so there's a fascinating possibility here. Perhaps the galaxy was overflowing with life billions of years ago. Perhaps it still is. Perhaps currently, distant from us, there are societies conducting their activities. However, we're separated by such immense distances and such immense stretches of time that we never encounter. We never exchange messages. They become extinct, or they depart, or they transform into something we can't identify. And millions of years afterwards, fresh societies emerge and undergo the identical experience. This represents what science terms the cosmic shuffle, societies passing one another in the darkness. Now, I want to discuss what might trigger a society's conclusion, because this is significant, and it returns us to that great filter concept. When you examine the history of human civilizations on Earth, you discover something fascinating. Civilizations ascend, they become advanced, they create technology, and then they collapse. Occasionally, they collapse because of external factors, invasion, disease, climate alteration. But frequently, they collapse because of internal factors. They exhaust their resources. They contaminate their surroundings. They wage conflict. They become unstable. Now envision that pattern on a galactic magnitude. Envision that this represents simply what occurs when a species becomes intelligent enough to create technology. That identical technology provides them the capability to annihilate themselves. Nuclear weapons, biological weapons, artificial intelligence that rebels against them, climate-modifying apparatus, and perhaps, just perhaps, every single society that achieves that point of technological advancement encounters the identical crisis, and the majority of them don't survive it. Some researchers have estimated that the typical duration of societies might be merely 1,000 years. 1,000 years out of billions, that's an instant. That's insignificant. If societies last merely 1,000 years on average, and if they emerge intermittently throughout the galaxy's history, then the likelihood of any two of them existing concurrently and sufficiently near to exchange messages is incredibly minute. You could have millions of societies throughout cosmic history, yet they'd nearly never encounter. There's another perspective to this that I find captivating. It concerns what's termed the rare Earth hypothesis. The concept is that while planets might be common, habitable planets might be common, planets with life might be somewhat common, planets with intelligent life might be scarcer, and planets with intelligent technological life might be extremely scarce indeed. Because each stage requires not merely chemistry and physics, but fortune, extensive fortune. Earth experienced fortune. We experience fortune with the moon, which regulates our climate. We experience fortune that we weren't struck by a massive asteroid at the wrong moment. We experience fortune that multicellular life developed. We experience fortune that mammals endured the extinction of the dinosaurs. We experience fortune that primates developed intelligence. And we experience fortune that our intelligence possessed precisely the appropriate characteristics to comprehend physics and construct technology. If any single of these factors had occurred differently, you wouldn't be present viewing this content. You wouldn't exist. The universe wouldn't have generated us whatsoever. Now, multiply that fortune by everything that must occur for a society to persist for billions of years without annihilating itself. It's nearly unattainable. So here's what I believe is occurring. I believe intelligent life has probably developed multiple times in our galaxy. Perhaps many times, perhaps most frequently. When you possess a habitable planet for sufficient duration, something eventually develops intelligence. However, that intelligence doesn't persist. The societies that develop don't survive. They encounter a great failure. They annihilate themselves, or they transform into something we wouldn't recognize as a society any longer. And this indicates that currently, as I'm addressing you, the societies that existed 10 million years ago have vanished. They're extinct. They abandoned no evidence. The galaxies isn't filled with their remains, or their objects, or their enormous extraterrestrial cities, because civilizations are youthful. They're fleeting. They're similar to mayflies on a cosmic magnitude. We might be inhabiting a galaxy filled with extinct societies, ghost worlds where advanced beings once roamed. However, now there's nothing. Quietness, merely the gradual decay of stars and the enlargement of space. Now, what does this signify for us? What should we do with this understanding? Well, initially, I believe it should humble us. We prefer to believe we're exceptional. We prefer to believe we're the most intelligent beings in the cosmos. However, we might be one of millions of species that have achieved this point and encountered the identical crisis, and we might be about to commit the identical errors. Secondly, I believe it should drive us. If societies don't persist very long, that indicates every society that succeeds, that genuinely navigates through that crucial period and endures long-term, is accomplishing something nearly unattainable. It's performing something that millions of other societies failed to accomplish, that holds significance, that merits striving for. And thirdly, I believe it should cause us to contemplate what specifically constitutes the great filter for us. Does it lie behind us? Have we already traversed the crisis point? Does it lie ahead of us? Are we about to confront the identical challenges that obliterated every other society that preceded us? Are we positioned at the edge of a precipice? Because here's the crucial point. If the great filter is genuine, and if it lies ahead of us, then we're in authentic peril. And not merely from external factors, from ourselves, from our personal technology, from our personal decisions. You understand, when I contemplate this, I reflect on that researcher, that brilliant physicist Enrico Fermi, and I reflect on how he inquired, "Where is everyone?" and how troubled he was by the quietness. He was troubled by it because the mathematics didn't align. However, I wonder if he would have been less troubled if he had contemplated this timing dilemma. If he'd understood that the quietness might not indicate there's nobody out there, it might merely indicate we're all solitary, all by ourselves in our personal tiny fragment of time. And perhaps that's actually a form of compassion because it indicates that our actions hold significance. The decisions we make in the upcoming few hundred years, whether we annihilate ourselves or discover how to endure sustainably, whether we contaminate our world or restore it, whether we develop artificial intelligence responsibly or carelessly, those decisions hold enormous significance because we might be the exceptional ones. We might be the civilization that succeeds, that endures the great filter, that becomes space traveling, that expands across the stars, or we might fail. We might join all those other societies in the quietness, but at minimum we possess a choice, and that choice belongs solely to us.